Hello friends, welcome back to this channel. Today we'll continue with the textual exercise of chapter number 3, that is current electricity. Okay, so let's start with question number 1. 3.1. The storage battery of a car has an EMF of 12 volt. Okay, so EMF is equal to 12 volt. And the internal resistance, we will use the symbol small r for internal resistance, that is 0.4 ohm. What is the maximum current that can be drawn from the battery? Okay, now let's say if a battery is connected to an device having a resistance R. Okay, so this is the EMF and this is having internal resistance R. Okay, this is the internal resistance of this battery. The formula for current flowing through the circuit is epsilon upon R plus R. But now the question is maximum current. Now see, the value of EMF epsilon and R, that is internal resistance, is constant, right? So lesser the value of capital R, that is the resistance of external device, higher the value of current. Okay, so for maximum current, R must be equal to 0. So what does that implies? That implies I max will be equal to epsilon by R. What is the EMF? That is 12 volt and internal resistance 0.4. So 4 3 is 12. At 0.4, so it is equal to 30 ampere. So the maximum current that can be drawn from this battery is 30 ampere. Clear? This was about question number 3.1. Just note it down. Okay, remember this formula. Current flowing I is equal to V by R. Here what is V? That is the EMF epsilon. And what is the resistance? Internal resistance plus this external one. The question is maximum current. That is the reason why we have taken capital R is equal to 0. Okay. Now let's move to the next, that is 3.2. 3.2. A battery of EMF 10 volt and internal resistance 3 ohm, 10 volt and 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, what is the resistance of the resistor? Second question, what is the terminal voltage of the battery when circuit is closed? Okay, so let's take battery connected to a resistor. Let's the resistor. Let the resistance of the resistor be R. Okay, what is the EMF of the battery? That is equal to 10. Internal resistance of this battery R is equal to 3 ohm. Okay, so what I will do, I will take this as a complete battery with internal resistance. This is the external resistance. Okay, now the question is the current here it is zero point 0.5 ampere, then what is the resistance of the resistor? Here it is given that I is equal to 0.5 ampere. Okay, now we know that the formula for the current flowing I is equal to epsilon upon R plus R, right? So 0.5 equal to 10 upon R plus 3. So cross multiplied 0.5 R plus 1.5, 0.5 to 3 equal to 10. This is equal to 10 minus 1.5, that is equal to 8.5. Okay, So R is equal to 8.5 upon 0.5. 17. Okay, it's 17. So the resistance, external resistance or the resistance of the resistor is 17 ohm. Okay. Now the next question is, what is the terminal voltage? The formula for terminal voltage E is equal to EMF with epsilon minus IR. What is the EMF? That is 10 volt minus the current flowing here, that is given to be 0.5 ampere. Internal resistance is 3. This will be equal to 10 minus 1.5. So the terminal voltage is equal to 8.5. Okay. I'm repeating what I did. I used the formula I equal to epsilon upon R plus R. Put on the value of I, epsilon, and the internal resistance, and found out the resistance of the resistor to be 17 ohm. For terminal voltage, I use the formula V equal to epsilon minus I R. Okay, so that was about question number 3.2. So just note it down. Now let's move to the next, that is question number 3.3. 3.3, there are two questions. First, three resistors, 1 ohm, 2 ohm, and 3 ohm, this is the resistance of it, are combined in series. What is the total resistance of the combination? Okay, so I'm taking R1, second R2, third R3, sorry. R1 equal to 1 ohm, R2 equal to 2 ohm, and R3 equal to 3 ohm. Okay, point A and point B. Now see, R1, R2 and R3. These three are combined in series. So the equivalent resistance will be equal to R1 plus R2 plus R3. That will be equal to 1 plus 2 plus 3. So R equivalent will be equal to 6 ohm. Right, so this is the equivalent resistance. Okay, now B, if the combination is connected to a battery of EMF 12 volt, let us connect to a battery having EMF 12 volt. Now you have to find out the potential drop across each resistor. Now see, it is given negligible internal resistance, right? So this means that I can take small r equal to 0 compared to R1, R2 and R3, negligible. Okay, so now for finding out the potential drop, I need to find out the current, because for potential drop I will use formula V equal to I R. Okay, so now the current flowing here will be equal to EMF upon R equivalent. I'm not using internal resistance because it is negligible. So this will be equal to 12 upon 6. R equivalent is 6. So this is equal to 2 ampere. Okay, so the current flowing in this circuit is equal to 2 ampere. Now we know that in series connection, current flowing through each resistor will be same. So here I1 will be equal to I2 will be equal to I3 will be equal to I, and that is equal to 2 ampere. Okay. Now The voltage drop across first resistor. Voltage drop V1 will be equal to IR1, that is equal to 2 into 1, that is equal to 2. V2 will be equal to IR2, that is equal to 2 into 2, that is equal to 4 ohm. V3 is equal to IR3, that is 2 into 3 equal to 6 ohm. So the voltage drop across the first resistor is 2 ohm, across the second resistor is 4 ohm, across the third resistor is 6 ohm. Also 6 plus 4 plus 2, that is 12. The battery is of 12 watt. Yeah. So this was about question number 3. Just note it down. Now let's move to the next, that is 3.4. 3.4. Three resistors of 2 ohm, 4 ohm and 5 ohm are combined in parallel. What is the total resistance of the combination? The second, if the combination is connected to a battery of EMF 20 volt and negligible internal resistance, determine the current through each resistor, the total current drawn from the battery. Okay. First, let's draw three resistors connected in parallel. R1, R2, and R3. Okay, let this point be A, this be B. R1 equal to 2 R2 equal to 4 R3 equal to 5. Now see, as R1, R2 and R3 are connected in parallel, 1 by R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by 2 plus 1 by 4 plus 1 by 5. Okay. So LCM it will be equal to, or else directly multiply 5 4 so 20 20. So LCM will be equal to 20. So 2 tens are, so 1 into 10 10. 4 fives are 1 into 5 5. 5 fours are 1 into 4. 1 upon R equivalent, that is equal to 10 plus 5 15, 15 plus 4 19 by 20. R equivalent resistance is equal to 20 by 19 ohm. Okay, that is 20 by 19 ohm. Okay, so this was the first question, R equivalent. Now, second, if the combination is connected to a battery of EMF 20 volt, let's connect it to a battery having EMF 20. Okay, let this battery have EMF equal to 20 volt. And the internal resistance is negligible. So compared to R equivalent, small r will be equal to 0. We have to find out the total current drawn from the battery. Okay, so first epsilon equal to IR, or else here I can use the formula the current flowing I is equal to epsilon upon R equivalent. I'm not using plus small r because that is internal resistance is negligible. What is the EMF? That is 20 volt. R equivalent 20 by 90. Cancel. So I is equal to 90 ampere. Okay, so what is this? The current, total current from from the bed. Okay, this is the second part of B. First part is that it is asked determine the current through each resistor. So let the current through first resistor be I1, second be I2, and third be I3. Okay. Now we know the formula V equal to IR. That implies I is equal to V by R. So current flowing in the first resistor I1 will be equal to V by R. Now here see, as these three are parallel, okay, V1 will be equal to V2 will be equal to V3. That will be equal to EMF of the battery, that is 20 watt. Okay, so I'm taking this as V. I1 V by R1, that is 20 upon what is R? 20 into, sorry, R1 is 2 ohm. So 20 upon 2, that is equal to 10 ampere. The current flowing through R1 is 10 ampere. I2 V by R2, that is equal to 20 upon what is R2, that is 4 ohm, that is equal to 20 by 4, that is 5 ampere. I3, that is the current flowing through resistor R3, that is V upon R3. So 20 upon what is R3? 5. So that is equal to 4 ampere. So the current flowing through first resistor R1 is 10 ampere, through second resistor R2 is 5 ampere, and through third resistor I3 is 4 ampere. Clear? So this was about question number 3.4. Just note it down. Okay, students. So that's it for today. Today we have completed the first four questions of the textual exercise of chapter 3. In our next video, we'll start with 3.5. Okay, thank you.